The Superflux harness swap is something that's been requested a lot for me to do a video on, so here's me doing that. If you do not know how to remove your stator, there are plenty of tutorials already online for that. So you're going to need to go ahead and find that tutorial and then come back to this one. My best tip though is to use one rail to first break loose the hub bolts on either side, and then use the rail here to help lift the stator out of the hub. For example, and then while you're already here, make sure you're not pressing anywhere near the PCB. And because you broke the hub bolts loose with the rail before you opened it, now getting these undone while you have no real grip anywhere ends up being a lot easier. So now we have our stator open and we got to break these free. While you're snipping, you need to be very careful to not clip any of the copper. Make sure you're only getting the twine there. Do not cut the copper. Just like all of the other harness options, in the harness that you're trying to replace right now, you have 9 connections that need to be disconnected and then reconnected with the new harness. Those 9 connections are the 3 large wires, blue, green, and yellow, for the phase wires, and then you have 6 small communication wires that are for the hall sensor board. It's the same thing with GT, 1, 2, 3, and then 6 up top. And over here, the old XR one, your phase wires had to be split into 6, but just count these 6 as 3. 1, 2, 3, because these were inferior pins that couldn't handle the current, and 6 connections here for the hall sensor board. Just like here, you have yellow, green, blue, and then you have 6 connections on your hall sensor board. Your best bet is to take a photo of this before you do anything to make sure you can reference it later on. The only difference between the old harnesses and the new Fungineers harness is the Fungineers harness actually has 7 smaller connections, making 10 in total instead of 9 like the standard GT. Your extra wire is colored gray. You do not need the gray wire. Now, unless you've gotten lucky, after you've removed your heat shrink wraps off of your phase wires, they most likely look like this, where you have a good solid, like ½ inch there of wrapped and soldered material. No, you do not need that much of a joint to safely carry the current for one phase wire. Not only that, once you snip these, you snip these pretty much right where you have a couple twists. So right about there. So once you snip them right there, you're going to have a lot easier time desoldering, and you're going to have less stuff to have to manage once you get everything reattached with the new harness. Now you can see I've snipped those down to where the copper makes a nice solid entrance into the wire and makes like one solid twist, and everything is still connected. Okay, so while my iron is heating up to super effing hot, because I want to heat this shit up super quickly, I have marked off the color of the copper that the wire is being attached to. I do this beforehand just in case I may have multiple motors that are meant to go to the same controller. Doing it this way, you're going to have a lot better chance of having a quick swap motor. Well, unless you're going from hypercore to superflux. If it's the same motor, as long as you match up these phase wires correctly, since Future Motion did the same, yours should theoretically all be easily plug and play. So I've got my really hot iron. I've got a good amount of solder, and we're going to pretty much flood these wires in partnership with using a pry bar of sorts to kind of help separate them, since we already chopped off those extra twists. So that's what we're going to do now. We're going to get it nice and hot, and we got to get this nice and hot. And there's one. Two. Three. Now that all three phase wires are desoldered, which is the hard part, and you've obviously taken a picture of the order of these wires, we can now desolder these wires here. Not these three yet. We're not doing those yet. All right. So now that you have all 9 connections desoldered and you got your boots on, what you do is you make sure you separate all of the connections that are going to be taken out, and put your hard heels on either side. And you are not pushing with your feet, you are only pulling with your hands, with your feet being used as a backstop. So, just like that. If we push too much that way, we risk propelling the motor in front of us. So we pull with the heels as a backstop. And now, if you look inside, you'll now see the reason why we needed our long, strong-handled, pointy stick. Because you're about to go straight Jason Voorhees type shit on this, man. You got to stab the shit out of this. I can't record this part because it's pretty aggressive. So any way you can get that gunk out of there, you get it out of there. So when you're finished, your axle should look somewhat similar to this, and your workbench should look somewhat similar to that. So now that all connections are desoldered, the axle is clear. The next step is to get the harness into the axle itself. But here's the thing. There isn't a single configuration that takes this long of a harness. But at the same time, there might be. So we're going to go ahead and use every inch of this harness that we can. And how we're going to do that is, once we're able to get this little peckerwood guy here right through that little itty bitty hole, we are then going to actually force the harness down into the axle like so. like that. So that's kind of how it's gonna look once we're in there. And going in here is really not that difficult. Once you get the heat shrink in there, take the angle tweezers, just give yourself a little hook. What I had to do was just kind of go in the hole and fist the bottom out like that. Now that I have that in there, I can now pull this through like that. Now our hypercore got a little bit of a hard on there. We're going to keep feeding it. And you want to pull at the same time that you're pushing. All right, so now we have reached the point where the heat shrink is in through the axle. And now what we have to do is actually pull up like this and push down at the same time. And eventually you'll feel that harness sort of go from up to down and up. And it takes some work. It's going to take a minute. So now that you have a majority of the harness tucked away in the axle, you can still get a couple extra folds in there if you want. But as long as you got something going from this is the entrance point, that way and then back up, we're cooking with gas. Now we just need to remove this heat shrink and then line up our colors. Line up our color wires to our colored copper and then get them resoldered again. See, just nice little 1/8 of an inch or so of a solid connection. That's really all that's needed. So now we have our connections tied down where they will not interfere with the top cap. A little tip for when you're trying to get your wires appropriately cut. Give yourself just the tiniest bit of slack. Don't measure it from right next to the angle and then to the board. Let it go a little bit wide, because your biggest mistake here is cutting it just a hair too short. You just want you can manage a tiny little bit of extra length, but if it's too short, ain't shit you can do about it. So here comes the part in which you may have needed the extra Hall sensors, because you have two choices. Once you have these cut appropriately, you can stick them through the top of the PCB, or you can do it like it was originally, which is up through the bottom. Now, going up through the bottom means you're going to have to remove this plate, because there is a little piece of paper in there that makes getting that wire and sticking it up in this tiny little hole and getting it in there cleanly without stray wires, it makes that next to impossible. So you can either strip and then stick them in through the top, or you can strip and stick them in through the bottom. But sticking them in through the bottom means you have to remove the PCB, which also means you need to desolder these Hall sensors. Now, the reason you might have needed the extra Hall sensors is because if you see these are not wires. These are just pieces of metal. And every time you bend that piece of metal, you compromise its structural integrity. And in order to get this PCB off, I need to desolder and carefully move these out of the way. So anytime I move this, I am risking these Hall sensors, which is why if you prefer going in through the bottom like I do to save myself some clearance on the top, then you might just want to have a few of these around just in case one of these guys breaks off. If one of them breaks off, your Hall sensor is bad. It needs to be replaced. So as you can see, I have the silicone in there that's helping to immobilize those wires so they don't bounce around in that little hole. And after preemptively putting on a little bit of heat shrink around the 6 wires, because I knew I wanted to try and go in through the top, because I just didn't feel like dealing with the Hall sensors this time. And when going through the top, you still have a good amount of clearance. So, I mean, you could do it either way. It's simply the regular way to go in through the bottom. But make sure to replace your gaskets. Okay. There we go. That's it. That's what we're looking for. See here, no contact is made. We got a good amount of clearance all the way around. So I just so happen to have a build here with a confirmed functional controller side Superflux setup that I can run motor configuration on. All right, on FLC detection, start. And we have detected Hall sensors. So if you did everything correctly, you should have gotten a Hall sensor detection that was successful. If your Hall sensor detection was not successful, you need to go through and confirm all of your wiring is good. All of your wiring is good. Make sure that there are no shorts between your solder joints on the PCB. Make sure there are no pinches as a result of you kind of maybe working it, or maybe the tool that you use might have been a little bit too sharp. I use this little flat guy to help just kind of direct the harness in so it will fold and loop properly. Make sure you if you're going to do that, carefully select that tool. So just go through all of the hardware things. Maybe your Hall sensor got damaged when you went to remove the harness. Go through and check each of those little prongs. But yeah, that should take care of it. And good luck with your own harness swap. Float on. Deuces.